Hello again. This lecture is on performing mensuration and calculation, and we have two learning objectives. The first one is to select components to be measured, and the second is carry out mensuration and calculation. So we're going to start with the definition of terms like amperage or AMPS. It means a unit of measurement of electrical current flow. Then we have ampere, a unit of measurement which describes the amount of electric current passing a certain point at a particular time. Then we have centimeter or the hundredth of a meter. Inch, a portion of a foot, which is an English unit of linear measurement. Then we also have millimeter, one thousandth of a meter. Ohm, the unit of measurement used to express resistance. Then we have volt, a unit of measurement of electrical pressure or voltage. Then we also have to know some of the gadgets that we use. Okay, we have the multitester, or we also call it the multimeter. It's an electrical measuring instrument used to measure the voltage, the resistance, or the current of a circuit. Then we also have the ohm meter. It's an instrument used to measure the resistance in ohms. Then the voltmeter, it's an instrument especially designed for measuring the voltage. And we also have the wire gauge used to measure the diameter of magnetic wire. This is used for the electrical parts of automotive. Then, some terms like accuracy or the precision of results as a mathematical solution which is free from error. We also have to have understand calculation, which is the process of working out the answer by solving mathematical problems. Compression pressure gauge, an instrument of checking the compression pressure of the engine. Maintain, ensure that something continues to work properly by checking it regularly and making repairs and adjustments if required. Then maintenance, the periodic upkeep of something such as tools, equipments, and the workplace. Then you also have some other terms like measuring, oil pressure gauge, safety, standard procedure, techniques, tolerance, and VOM. And all these ones will be um, dealt with later as we go further. Then measurement is the process or the result of determining the ratio of a physical quantity such as length, time, temperature to a unit of measurement such as the meter, second, or degree Celsius. The science of measurement is called metrology. Metrology. So it's very important that your knowledge of the different types of amplifications of measuring instruments play a vital role in the development of your competency. Like any other task, components to be measured must first be identified before using any tools. And identification of components will determine the right tools to be used. It will make your work faster and even easier without going back and forth because of the wrong choice of tools. To understand it more, a precision instrument like a vernier caliper is not as good in getting a diameter of oil, for example. But getting the diameter of a bearing or a thickness of a shim using this kind of precision tool is much better. So see, there is a proper measuring tool for each equipment. So what are the different kinds of measuring tools and the precision measuring? It's divided into four. We have the mechanical use, electrical use, pneumatic use, and the hydraulic use. So we're going to start with the mechanical use. The two instruments that I have in here on the screen is called are called the vernier caliper and then the micrometer caliper. So they are usually used in measuring the diameter of engine crankshaft and camshaft journals, pistons, and valve adjusting shim. So the vernier and micrometer calipers are both precision instrument that can measure even the smallest and tiniest thickness and the diameter of an object. the thickness of these objects, small objects, are very crucial for the car to to be used properly. So these engine parts need to be measured in a precise way. That's why we need the vernier caliper and then the micrometer calipers. So these two can be bought equipped with digital or analog reading. Yan. This will lessen the time consumed in analyzing the reading of the data because of the direct data available as you measure the part. So next, we have the dial gauge. So the dial gauge is an instrument that measures the thrust or the backlash. So it's a backlash is a result of force that comes from an abnormal clearance or gap between two parts, as in in the differential gears. So when two parts wear out, slack is developed and backlash is the result of it. Therefore, we need to have our dial gauge to get the clearance, and so with the engine valves. It is more accurate than feeler gauge. Yeah, feeler gauge is being used, but this one is even more accurate. The movement or pointer in the dial gauge determines the amount of the backlash being measured. For electrical use, we have the ohmmeter or the voltometer. We call it the VOM. So otherwise called as multitester, is used to measure the voltage, the resistance, and current of the circuit. It is connected in parallel or series with the circuit depending on what to measure. Okay. So next, under electrical use, we also have the meter tester. So this is an instrument in finding out grounds and shorts in a motor. A good example to test is the starter motor. So when the starter motor is subjected to a meter test, a flat, thin piece of metal, like a hacksaw blade, is placed above the starter motor. When the Meager tester is turned on, the starter motor is rotated. A spot where the hacksaw blade is attracted means that the starter motor is faulty and need to be repaired or replaced. Yeah, you don't know what the problem is, but because of the use of the Meager tester, you have found out that there is a problem with the motor. Next is the engine analyzer. So it is a compact instrument that tests and measures the following. What are these? Contact point resistance, ignition coil resistance, battery voltage, ignition current flow, engine revolution per minute or the RPM, the dwell and the cam angle, and also the alternator diode. Okay, next. We have the timing or the strobe light. So this is a device that produces stroboscopic effect from ignition pulses. Ignition timing is achieved by aligning the timing marks on the crankshaft pulley and timing cover of the engine. Okay, so timing is very important here for the crankshaft. So for you to be accurate, you use the timing strobe or the timing or the strobe light. For pneumatic use, we have the vacuum gauge. It's an instrument that measures the atmospheric pressure drawn by the engine. It is also used to find out the air-fuel ratio of the engine. Another under the pneumatic use is the compression gauge, which is an instrument that measures the compression measure of the engine cylinder. Then you also have the radiator pressure tester, which is used to test the cooling system or internal and external leaks and to make sure that it has the ability to hold pressure. Then, for hydraulic use, we have the fuel pump pressure tester. It's an instrument uh, that has the capability to check the pump. Okay. So a ruler is a tool used in, for example, geometry, technical drawing, engineering, and carpentry. Yeah, strictly speaking, yeah. But this is somewhat kind of a ruler, but it measures the pressure. Okay, so that's the fuel pump. Then you also have the hydraulic use. So this one, for hydraulic use still, you have the oil pressure gauge. It's an excellent indicator instrument that determines the pressure of oil flowing. Also, we have the temperature gauge. It's an instrument that determines if the engine temperature is normal or is it overheating already. Then techniques in measuring and determining tolerance of parts. So there are many ways in measuring a part or component, but there is difficulty when using precision instruments, especially those that require a minute data. So the process in which parts are measured needs to have a corresponding data of specifications so that a clear and objective result is attained. Using specific measuring instrument for a specific part or system to be measured is highly recommended. Specific measuring instrument is designed for specific part or system. So using different instruments other than what is required will give you vague or incorrect result. That's why you have to use the specific instrument and then use it properly. So, in order to apply techniques and determine tolerance, some considerations are recommended for consideration. The first one is use the manual specifications. Yes. Then use the principles of general rule and of course use the professional experience. So the manual specifications, if there is an available manual, we should not neglect it and we should use it. Without this manual, the user will only be guessing on the corresponding value of measurements. For examples, are this. So the bolts. A good example is the kind of bolts being used. A bolt made of high-grade carbon steel has a big difference compared with a bolt made of low-carbon steel, even if it has the same size. So when a low-carbon steel bolt is tightened using the torque data used with high-grade carbon, it will easily give up and break. So see, so you have to have the manual for you to know the specifications or the components of these materials. Okay. Next one is the ignition coil. So vehicle electrical component like ignition coil, primary and secondary windings have specified resistance data, but tolerance is also given. It means that when the resistance reading is above or below the standard reading, but within the limits of its tolerance, it is said that the resistance is acceptable or tolerable. And you can only find that in the manual. Also, the use of precision instruments and tools has tolerance also, like mechanical measuring tool, like torque wrench, have tolerable life cycle. If it exceeds its cycle or length of use, a metal fatigue will be developed. Its effectiveness to accurately measure the tightness of bolts or nuts will be affected also. That is why it must be calibrated before and after use. So the delicate precision tool like a vernier caliper and micrometer must be used with caution. It is made with a very light material that a sudden impact or force will damage its scale and calibration. Eh di wala nang gamit kung nasira na. Next, the extent of tolerable limit must be determined so that the outcome of the process can be achieved without affecting other factors. So sometimes a manufacturer allows a general rule when considering the tolerance of parts. They include plus or minus rule. Even with the availability of specification manuals, manufacturers accept it but do not tolerate using it even though it does not cross the maximum limit of tolerance. So not all parts or systems can be applied with this kind of principles. The extent of tolerant limit must be determined so that the outcome of the process can be achieved without affecting other factors. So an application of the piston ring and the clearance is a good example for this, as you can see in the picture. Even without the aid of specification manuals, the principle of general rule is applied by multiplying the piston diameter by 3 thousandths of an inch or 0.003 inches, and you will get the acceptable piston ring and clearance. Okay? The last one is the use of professional experience. This can be done if a person or user has a vast, wide, and long experience working on a specific task. A novice worker must not involve himself in duplicating this kind of ability. Okay. Next one, we have the methods of calculation, conversions of units and measurements using mathematical formula. So I'm going to show you a table from the English to metric and from metric to English. Actually, you can find this one everywhere. It's everywhere in the internet, so you can get a copy. Then we have here the temperature formulas. Okay, if you'd like to turn Celsius to Fahrenheit and Fahrenheit to Celsius or Kelvin to Celsius. Okay, so those are the things that you have to remember. Okay, the tools and how to use them properly, how to take care of them properly. Thank you very much and enjoy. I'll see you again in the next video.